So today we're going to be talking about section 3.3, which is the addition rule. Now, addition has to do with what are called mutually exclusive events. And so two events are mutually exclusive if they cannot occur at the same time. Okay, so here's exactly what it would look like. So A and B don't occur. Now, something that is not mutually exclusive is when there's some sort of overlap, something that can happen at the same time, right? Those are considered not mutually exclusive. So let's look at an example. Example 1 says this, rolling a 3 on a die and rolling a 4 on a die. Can those happen at the exact same time? And the answer is no. So these are considered mutually exclusive, okay? When they cannot occur, they're mutually exclusive. All right, let's look at the next guy. Next example says a randomly selecting a male student and randomly selecting a nursing major. Well, the question is, can you have a male nursing major? The answer is yes. So these are not mutually exclusive, and I'll abbreviate from here. Okay. 3, randomly selecting a blood donor with type O blood, randomly selecting a female blood donor. Well, females can also have O blood, so these again are not mutually exclusive. Okay. Here's a couple guided practice problems that you can try on your own as well. Now, here's where the addition rule comes in. It goes like this. The probability of events of A or B occurring is the probability of A plus the probability of B minus the probability of them both happening. Now, that has to take into account for events that are not mutually exclusive. Anything that is mutually exclusive, we're just going to add the probabilities of A and B because there is no overlap of A and B at the same time. Okay? So let's look at example 2. It says you select a card from a standard deck. Find the probability that the card is a 4 or an ace. Okay? So for number 1, we're looking for the probability of a 4 or an ace, right? So we think about it. Okay? Can you get a 4 or an ace at the same time? And the answer is no. So these are mutually exclusive. And so we're just looking at what's the probability of a 4 and the probability of an ace, right? And so the probability of a 4 would be 4 out of 52, which is 1 out of 13. Probability of an ace is also 1 out of 13. And so the probability would be 2 out of 13. And we could write that as a decimal just by dividing. Now, number 2, it says you roll a die to find the probability of rolling a number that is less than 3 or rolling an odd number. So probability of less than 3, so less than 3, or an odd. Okay, so let's think about it. So the probability of less than 3, okay, probability of less than 3 plus the probability of an odd, okay, and then the question is, can you have a number that's less than 3 and odd? And the first number I think of is actually 1, and that's both odd and less than 3. So we have to do minus the probability of an odd less than 3. So we'll just say the probability of, well, the only one I can think of is 1, okay? So the probability of picking a number less than 3 would be 1 and 2. You get a 1 or a 2, right? So that would be 2 out of 6, because there's 6 number cubes, or sides on a number cube. The probability of an odd, that would be 1, 3, and 5, so it'd be 3 out of 6, minus the probability of getting a 1, which is 1 out of 6, right? And so since they're all common denominator, 6, 6, and 6, right? So 3 or 2 plus 3 is 5, minus 1 would be 4 out of 6, which would be 2/3. Oops. So the probability would be 2/3. Okay, or I'll write it over here better. 2/3. Okay, and this one was 2/13. Here's a couple guided practice problems that you can try too. Now, it says find the probability of mutually exclusive events. The frequency distribution shows volumes of sales in dollars and the number of months in which sale representatives reached each sale level during the past 3 years. If the sale pattern continues, what is the probability that the sales representative will sell between 75,000 and 124,999 next month? Okay, so if the sales pattern continues, all right, so what we're looking at is we are going to say, okay, well, how many months are everything? Okay, well, the total number of months is 3, 5 would be 8, plus 6 would be 14, then 21, 23, 24, 25, 26, 27, 28, 29. So it'll be out of 29, right? Okay, out of 29. And so the probability of getting between 75,000 and 125 would be the 7 and 9 together. So that would be the probability of the first one, which would be, well, I won't write it. I won't use this notation. I'll just add them. Okay, so it'd be 7 out of 29 plus the probability of the other one, which is 9 out of 29. And so that would be 16 out of 29. Okay, 16 out of 29. So I didn't do a very good job explaining it. Basically, what it is we look at the months, that we find the total number of months, which is 29, and we just say if the pattern continues. Well, if we know that it's been 7 in the past and 9 in the past, we just add them together. And since we know we want 7,500 to 124.99, we find the two areas in which they're right there, and we just add them. Okay? Here is one. It says, find the probability that sales will sell between 0 and 49.99. So here it is right here. 0 and 49.99 would be the first one, which would be 3 months and 5 months. So now you should be able to find the probability of them happening. All right. Now, here's another example. It says a blood bank catalogs the type of blood, including positive and negative Rh factors, given by donors during the last 5 days. The number of donors who have given each blood type is shown in the table. A donor is selected at random. So it says find the probability that a donor has type O or type A. And then the second one is find the probability that the donor has type B or is Rh negative. So first one, probability of O or A. Okay, well, the probability, first off, can you be O and A at the same time? The answer is no. So the probability of O plus the probability of A, which are mutually exclusive, so we don't have to subtract anything. Okay, so probability of O is 184 out of 409. Probability of A is 164 out of 409, which would be, let's go to our graphing calculator. So let's see, 184 out of 409 plus 164 out of 409. Okay, they give it to us as decimal, so 0.85, or you could say it's 348 out of 409. There it is right there, okay? Now, the second one says the probability that you get blood type B or Rh negative. Now, this one, if you think about it, you can be B negative, but you can also be A negative, O negative, all those things, right? So this one is not mutually exclusive, and we have to subtract the overlap. So probability of B or negative, right? So the probability of B plus the probability of negative minus the probability of B negative, right? We're going to get rid of what we overlapped, what we counted twice. And so we're going to do that. So the probability of B is going to be this 45 out of 409 plus the probability of negative. Now we can look over on the side. Probability of negative is 65, right? So 65 out of 409. And you'll notice, if you look at it, B is here, negative is here, and you'll notice there's one little spot, that 8. is B negative. And so we're going to subtract that 8 that's been double counted, right? And so let's go to our calculator, and we're going to say 45 out of 409 plus 65 out of 409 minus 8 out of 409. And we end up getting 102 out of 409. Okay. And here's one that you can try on your own. It says the probability of B or type AB, or the probability of O and RH positive. So I'll have you try number 2. I'll get rid of that. So O and RH positive. Try that one now. Okay, so basically, here's a summary of all that we've done in probability so far. There's classical probability, which is number of outcomes over the number in the sample space. There's empirical, which is the frequency of an event over the total frequency. We know that all of our probabilities are between 0 and 1. A complement is 1 minus the probability of what you're looking for. We have independent events, which is when we're using and we have mutually exclusive or not mutually exclusive when we're adding our probabilities. Okay? All right. So knowing all that, and it's in your notes, let's look at this right here. It says, use the graph at the right to find the probability that a randomly selected draft pick is not a running back or wide receiver. Okay, so first off, it says that there's 256, right? 256 players that were picked in the 2009 NFL draft. Now, we know that running backs accounted for 22 of them. And we know that wide receivers accounted for 34 of them, right? So what we're going to do is we're going to say, okay, so what's the probability of not a wide receiver or running back? Well, it's everything else, right? It's everything minus these amounts. So I'm going to take 256, and I'm going to subtract 22, and I'm subtract 34 from it, right? And so when we do that, 256 minus 22 and minus 34, I get 200, okay? So there's 200 left over. So the probability of not picking one of those would be 200 out of the 256 drafted, right? And you could leave it like that, or we could write it as a decimal, right? So that would be 200 divided by 256, which would be 0.78. And so that would say that about 78% of the draft is not running backs or wide receivers. Okay, here's a guided practice problem that you can try. Good luck, and let me know if you have any questions.